Hello everyone, welcome to the Azure Learning Series. This is Lakshit Pant from Azure Developer Community, and today we are going to kick off a bootcamp on Azure, Microsoft Azure, where we'll be teaching you what is cloud computing, what is Microsoft Azure, and how you can prepare for your Microsoft Azure certifications. What are the best way to prepare for it, and you will be we'll be having multiple speakers for multiple days for the entire bootcamp, where we'll be covering a range of topics including identity and access management, networking. There will be certificates for this bootcamp, so stay tuned for all the details. And talking about the Azure developer community, here you have we have 100 we are in 100 plus cities having all the Azure developer leads, and we are trying to facilitate each and every student with Microsoft Azure so that we can create a buzz around Microsoft Azure and help you build your scale your websites with the help of Microsoft Azure, so that you can step up the first take your first journey into Microsoft cloud of with Azure. So here we do offline sessions, online session. We would love to host you sometimes in Microsoft, as this is for Anurag University. So we would love to host you all sometimes at Microsoft Hyderabad premise. We organize the regular events there in Microsoft Hyderabad premise, and there is an event scheduled for next month. So hope to see you there. And we have the Bisom here who will be teaching you what is cloud computing, why you should learn it, and what are the benefits of cloud computing, and how it is relatable in real-time scenarios, and what are the applications specifically of cloud computing. So not wasting much more time, I'll quickly pass on the stage to Devasom, and he'll be explaining you what the cloud computing is, and he'll give you the hands-on session around it. Over to you, Devasom. Yeah, okay. Sounds like the Visum is fixing up some technical glitches. So till then, I can share you the Discord server link. You can join the Discord server. It's bit.ly is it Discord, and here we organize regular daily quizzes where you can get a chance to win Microsoft merchandise. These merchandise could be Microsoft cups, Microsoft t-shirts, and many more. So okay, that's bit dot. Just give me a second. That's bit.ly. Okay, just give me a second. Bit.ly is it Discord. So here is the link. The first link is wrong. So this is the link that you need to join. Copy this link, paste in your browser, and you can just start joining the Discord link. You can chat with multiple like-minded people over there. There we have some amazing Azure leaders over there who would be very happy to give you the roadmap, the resources to learn Azure, and a couple of things. If you have any technical doubt, technical queries around coding related questions, or maybe around your if you are confused about your career, you can definitely drop us a note on our Discord server. We have active community leaders over there who would be very happy to answer your questions whatsoever comes up. So this is the link. And also every day at 9 p.m. we regularly organize the quiz in our Discord handle. Okay, so you can definitely participate in this and get a chance to win Microsoft merchandise. So now we have the Visum over to you, Visum, for the cloud community sessions. Thank you.
Hi everyone. I hope I'm audible to all of you.
Yes, you are.
All right. So guys, from all of you who have tuned into the session, first of all, thank you so much. And while we start off, while I'm trying to set up a few other screens, uh, can I get your opinion about what do you think is cloud computing, or what do you think about cloud computing? Like, does it allow? Is it remote storage? Is it remote computing? Like, what's your opinion about cloud computing? What do you think it is? Cool. Um, Cloud computing provides dynamic resources which you can scale as per a requirement. That's kind of exactly what cloud computing does. Meanwhile, I'll try to share my screen from here so I can give you a more complete overview. All right. So yes, cloud. Cool. So cloud computing is like basically a remote server that is allocated to you. The only difference is that you don't get a screen, except you get a portal from where you can log in, join, manage, and kind of use the entire system as if it's your own on-prem instance. So before I get started, let me give me a sec. I'm trying to share my other screen so I can kind of whiteboard and explain to you.
नहीं मुझे नहीं
Cool, guys. I hope my screen is visible to you now. All right. So I'll start from the very basic, right? Like before the time cloud was the cloud as a concept was ever present, there was something called on-prem. So that's kind of usually my pedagogy. I first start with the dirty problem that existed, and then how we'll see how the solution that we are trying to learn today solve it. Because like no solution is good enough until and unless you see the dirty problem, right? You cannot appreciate a good solution. So let's start with the concept that existed before cloud computing came into being, on-prem or on-premise. So what basically happens in on-premise is, let's say I'll take one of you as an example. Let's say one of you have created a social media product, right? Let's say you created a social media. So Mark Zuckerberg created Facebook while he was in college. Let's say you created uh, iBook, for a lack of better word, for some other part of the body, right? So you created some social media, right? Let's call it iBook for now. Now, when you created this particular product, there are certain requirements that you need to kind of address. For instance, one, the for example, where does this data being where is this data being stored over the people who are joining your social media platform, the computing requirements that are required for running the services that you are going to provide, and the networking. Like for example, you cannot just say that my social media only works from 9 to 5 p.m. every day. It should be available throughout 24/7 hours, 24 hours of the day. So how do you ensure this availability, the availability of network and resources, scalability, elasticity, and we'll come to the rest of the topics later. So, for instance, first let's see what is availability. Now, let's say uh, initially the concept of cloud did not exist, so you went to the nearest brick and mortar shop and you got a server which has, let's say, 8 gigs of ram and maybe 20 core cpu, and let's say 1 terabyte of storage. Now eventually, let's say within a week of time, around, let's say, 50K users joined your platform, 50,000 users joined your social media platform. So now you realize that this 8 gigs of ram and this 20 core cpu is not going to hold up for the kind of load that 50,000 users bring to your system. So what you decided to do instead is you went to the market again and you brought another system, or let's say, which has 8 gigs of ram and another 20 core cpu set, and now you load balance the traffic from here, right? So what is load balance? Load balance basically means that this particular system will handle the 50,000 users, this particular system can handle another 50,000 users, and this has the load balancer is the entry point into one of your systems. So when a user comes to your platform, your social media platform, you write a piece of code, which for now we do not need to know how that code is written because it's a solved problem. We'll come into that later when we dive into the details. So let's say we have a piece of code slash vis-a-vis hardware software that is running, which we call the load balancer, and that's going to be an entry point. It will decide which server is having more traffic, and then it will divert the users into the other server. For example, let's say when this particular user u1 came into the server one, or our first system which we had purchased from the shop earlier, had 35K users live, and this had 20K users live. So the load balancer will send this new user into the new server, into the other server. So let's try to pause here and evaluate our situation. Let's say today we have 50K, tomorrow we have another 50K, and next down the next 2 to 3 months we have, let's say, another 3000K users coming to our system, right? 3000K is a good enough limit. 30 lakh users for social media is not a big deal, right? So let's say within the next 3 months we get another 3000K users. Now how do we solve this problem? I mean, if you think about it, this is going to change every day, because one, are you going to go ahead and purchase one system every day until and unless like every day when you hit 50,000 users? So what's the availability of your system? When you need another system for handling more load, can you do that on the fly? No, you cannot. You have to pause your project or your social media platform for a while, go ahead, go out into the physical world, get a new server, set up the load balancer, let the load balancer know that hey, there's a new system, you need to divert the traffic here as well, and then you're gonna scale. So what's the availability of your system? None, right? Your project goes down for some time while you're trying to expand or scale up. Then what's the scalability? Now the problem with scalability is, can it scale automatically? No, it cannot, right? When you notice that the total number of users are rising above 50K, you had to take a couple of manual steps, go into the store, get a new system, and then reroute the traffic into the new system. So your system does not scale automatically. It scales when you do a particular set of steps in order required, right? So, and what's elasticity? Elasticity is, let's say I have this particular system running, uh, and it has 8 gigs of RAM. While it is running and while it is having all the 50,000 users live, can I make this 8 gigs to 16 gigs without stopping the system, without rebooting the system, or without doing any change? No, I cannot do that, right? Because this is a real system. I have to go into the store, get a new stick of RAM, shove it into the new machine, and then reboot it, do any kind of BIOS or OS configuration required, and only after that I'll get another 8 gigs of extra RAM on my system. So that is elasticity. Elasticity says how elastic is the system. Can you plug in, plug out, upgrade, downgrade any particular part of the system without hampering the code, or without doing a downtime? No, we cannot do that in our original systems, right? We cannot do that. So these are a couple of problems that enterprises faced before cloud came into existence. Before cloud, on premise was the only way of taking your products out into the market. And for on-premise solutions, you had to build your own infrastructure, your own set of servers. You have to maintain it, you have to regularly upgrade it, or whatever steps are required. So coming to whatever steps are required, there are two kinds of things that we normally check for when we are comparing on-premise solution versus cloud. One, like apart from all these three, of course, which are required, how does a this things it's normally tough to explain to a business stakeholder. How do we explain the stakeholders that is cloud a better way to go ahead with, or is on-premise is the way to go forward? So there are two things. One, capex or capital expenditure, and then there is opex or operational expenditure. So capex. So all right. So basically, CAPEX stands for capital expenditure. What does that mean? Capital expenditure is okay. I'll give you an example. All of you have watched sorry, IPL, right? Now, what are the things that you need to watch IPL? Can you uh, just watch IPL for the minutes that you can you watch IPL by just paying for the exact minutes or seconds that you are watching, or you have to first buy a phone or a television, then buy a Geo subscription, and only after that you can watch IPL. So there is a set amount of money that you need to pay upfront to get a particular task done. In your example, for example, if for watching IPL, you need to spend some money in getting a mobile slash a television, a Geo subscription, and only after you pay all that money upfront for those resources, you can start watching IPL. That is capital expenditure, the money that you need to pay upfront to get your intention up and running. Your intention right now in this example is IPL, in cloud is our product or software, or iBox, iBooked as we named it, right? Then there is something called OPEX. OPEX is, for instance, let's say while you are watching IPL on a new phone after you have spent this capex, your system is breaking, your phone broke down, your screen guard broke down, anything happened which renders your device irrelevant or incapable of continuing what it was supposed to do. In your case, watching IPL, so you need to spend some money, get the screen replaced, get whatever things fixed, and those maintenance costs in order to keep a thing up and running are called operational expenditure or OPEX. So if you try to think from that perspective, can you guys guess what's the amount of money that we need to spend? Like how capex and opex are going to compare if we think of cloud, or sorry, before cloud, the solution that we had before cloud, on premise. So sorry guys, I just had my pet walking in. All right. So basically, if you now think about it, in this kind of infrastructure where all our servers or everything is on premise, we have a huge capital expenditure, right? We had to spend this kind of money in getting this monstrous systems, not one but multiple. And think about the kind of capital expenditure that we have to do if we want to support 3000k or 3 lakh users in real time, or 30 lakh users in real time. So the capital expenditure is huge, and it just keeps increasing and increasing, right? And what about the OPEX? Now, let's say while our project was up and running, this one of our systems, I'll switch to red so that it's visible to you, just stopped working. It could be for any reason. Let's say its RAM broke down, its memory crashed, there was a network mishap that happened, maybe the CPU burned itself. So, because CPU bursting is pretty common in devices which are running a workload for long periods of time, right? So you need to go out, take out that system from your infrastructure, and fix your machine so that it can start working eventually. So and your opex increases with that, right? Your operational expenditure, that the amount of money or the amount of expenses or investment that you need to put in for and keeping your system up and running after you have spent the capex, is called the opex. And in this case, both the apex and the opex are pretty high, right? Capex is significantly high, and opex is also tough. um, so to solve all this problem, uh, just a sec. So to solve all this problem, cloud came into existence, right? Some of the few cloud providers that first came into the market were AWS, Microsoft Azure, AWS, Microsoft Azure, and GCP. So now they're basically going to take some of the responsibilities away from your plate so that you can actually worry about focusing on the business logic and the product that you're trying to launch into the market instead of worrying about the infrastructure and all the nitty gritty details, right? So you might ask, like, why should you pay someone for doing this task which you were anyways managing yourself? Uh, that's business, right? For instance, imagine, why do you pay for water? Because someone someday decided to go out of their comfort zone, pack the water in a nice looking bottle, and you end up paying for it. So if you pay for something that's available in abundance in the market, no. So if you pay for something that's so abundantly available in the world and you can actually go ahead and get water for yourself, uh, now think about cloud, because here the cloud providers, for example, AWS, Amazon Web Services, Microsoft Azure, or GCP, the Google Cloud Platform, all of them take some of these responsibilities from your head, wherein you don't need to spend this capex, you don't need to take care of the opex. It will be taken care of by your cloud provider. So let's take the example of Microsoft Azure. So Microsoft Azure will pay for a data center wherein they have around, at least a single data center has more than 1000 plus servers or physical machines. So let's say now Microsoft has spent the capex already of getting of purchasing this data center for themselves, and it has more than 1000 physical machines. All of these machines have monstrous configurations, of course, that goes without saying. And then came a concept in cloud called hypervisor, or in combination with another concept called virtualization. Together they enable let me spell it down for you: virtualization. So the hypervisor is basically a hardware optimizer, which basically lets the software treat the hardware as a virtual device. And then virtualization basically is kind of an automation wherein you can divide a whole system into 10 to 15 mini systems. For example, if I have this single, consider one of the physical servers in a data center. Let's say it has 60 cores and it has 80 gigs of RAM. With a combination of hypervisor and virtualization, I can essentially treat it as a set of 10 virtual systems, each of them having 4 to 5 cores, which are enough for day-to-day purposes or running a basic server-side framework like Django or Node.js. So Microsoft spent the capex of set building up this data center for you, and on top of that they manage this hypervisor and virtualization combination, which lets their each of these system inside their data center to be treated as a set of mini virtual machines, and each of those virtual machines are capable enough to run a backend framework or a front end uh, tech stack if you want to. Of course, like, nobody can stop you if you want to deploy that, right? So having done that, having spent the capex, and also the other problem that we discussed, opex. So if anything goes down here, if any of the servers stops being responsive, it stops working, it malfunctioned, it burned itself, or even in cases of natural disasters like earthquake or flood, the money that will be required for getting the system back up and running, maintenances, daily licenses, compliances, all of those things are taken care by your cloud provider. OpEx. So again, those operational expenditures that are required are taken care. Now, so these are the few things that a cloud provider will always take care of you. Now, again, you might ask, like, what kind of control do you get if you shift from an on-premise wherein you had access to everything, starting from the physical hardware to the software or the operating system running on your machine, and coming to cloud, you kind of try to get an idea that you're losing some control at a fundamental level. It could be in terms of for a fact that machine is not on your premise, you don't know where the data is stored. It could be your control of choice of operating system was not found on the system, because now you are bound to run an operating system from a list of provider OSs, right? So how is this responsibility divided or identified? So there is a responsibility matrix called the SHR, sorry, SRM, or the shared responsibility model. Basically, what happens in your shared responsibility model is it's divided into three parts. One, always on the user, the variable part, and always on the provider. So imagine in here, let's say Microsoft Azure has a couple of thousand servers, right? Let's start from this example. Let's say it gives you a virtual access to one entire server, and now it's completely up to you. Whatever kind of operating system you want to install, you can do that. Whatever kind of networking you want that device to support, let's say you want it to be connected to some kind of different network, some different kind of SSD or storage, like the choice of storage device that is being used, the kind of RAM that your device gets, like you get a fundamental access to the entire device. And the only thing that Microsoft is taking care for you, or your provider is taking care for you, is the capex and the opex, wherein they have purchased the system, they're maintaining the system, and you're just using for the hourly usage of the system, right? You only pay for the hours that you're using the system, and you have the access to this entire device virtually. You can consider this access as a for instance, what you do on Jupyter Labs, right? If you have ever done machine learning on Jupyter Lab, you're given cells or code blocks where you just type the code, and uh, so if you compare to that Jupyter Lab example, you can just type your code in Jupyter Lab, but you do not have any kind of control over what kind of machine your system is running on. You don't know, like, you can only request for a GPU, but you don't know what GPU your system is using, and so on and so forth. You just write your code and it executes it. So you do not have much control. But in here, I'm telling you that you have all the controls that you need. The only difference is that you do not have that machine physically present in your home or surrounding or school, college, office, anywhere. It's present somewhere in a different remote location or a data center, where it is protected and maintained and cooled. Like all the cooling required, all the maintenance of the system are taken care by your providers. So if you think from that example, uh, herein you have a couple of responsibility: the security of the machine, what kind of operating system runs on the machine, the networking capabilities of the machine, the flavor of the machine, right? Like what kind of RAM, what kind of code, if what kind of GPU it has. And when you have those responsibilities, so always on cloud, let's first put these things. So always the responsibilities that are always on the cloud provider: the capital expenditure that needs to be spent, the operational expenditure, setting up the data center, servers, and maintenance. So these things are always on the cloud. Now, the first model that we discussed, we got to have control over the operating system, the networking capabilities, and we also get to choose the environment or the flavor of the machine, right? We got all those accesses. And apart from that, what are the other responsibilities that exist on us? So example, let's say we're running our social media platform on this machine. So the data of the users and the privacy of the users is on us, because that totally depends upon how you manage that data. If you choose to leak that data from your system, that's up to you, because again, it's your responsibility, since you have signed up for the network protection on your own, right? And to whichever responsibility models you move on, data and privacy of the user that are using your system is always on you, just like some responsibilities are always on the provider. Cool. So now let's move on to the second model. Now, in the first model, we had the entire system for us, an entire virtual machine. Now let's say if you have used Jupyter Labs ever or GitHub Code Spaces, then you don't get to choose what operating system your code is running on. You just choose, you just provide your code, you just provide the libraries that you're going to need, and everything is managed for you. So in there you only get to choose your code and dependencies. You just provide the dependencies that your code needs and your code, of course, and it is managed and run by your servers for you, or your service provider for you. And then comes the last but not the least, uh, another kind of model wherein you get a complete pre-built application which is running on the cloud. You just consume that data. For example, every YouTube is an example of this last model, wherein you have control over nothing. You are just an end user on that platform. You can watch YouTube, but you cannot change the logic of YouTube. You cannot change the, let's say you do not like a particular feature of YouTube, you cannot change their code and just get it removed. You have to live with it because it's not a system that is developed by you. You get very limited access, only the functionalities that are developed for the users. YouTube, Gmail, or any application that is installed on your machine and provides some kind of online functionality comes in this category. So now if you want, so now let's, these are pretty well heard terms. I just wanted to explain it to you clearly before telling you what it means, so that you, after that, you can relate. The first model that we discussed is called IaaS, or infrastructure as a service. The second model that we discussed, wherein we only have control over the code and the dependencies of the code, is called PaaS, or platform as a service. And the last model is called SaaS, or it's not the SaaS, that is the Gen Z term. This SaaS stands for software as a service, wherein you get an entire software running for you. So, all right, and these are a few of the providers that give you access to AWS, that give you access to this, do this, provide this access to machines for you in the cloud: AWS, Microsoft Azure, and GCP. So there are some managed services. For example, in infrastructure as a service, Microsoft Azure calls it VM, or Microsoft Virtual Machine. In AWS, you will get it by the term EC2, Elastic Computing Instance, and in Google Cloud, you will get it by the term CE, or Compute Engine. Now, these are examples of infrastructure as a service. If I move to platform as a service, Microsoft Azure provides you something called Azure Functions. These are event based triggers, wherein you just provide your code and you say that, hey, if something gets added to this particular endpoint, just trigger this function. So you don't need to take care of the machine on which your system is running. You don't even know on which machine your code is going to run. All you need to know is you have provided your code, you have checked for the errors, none exist, and now you have provided the code to Azure Function. It will take care of triggering your code, maintaining the lifetime of your code, and getting your work done in an event trigger asynchronous method. So that's platform as a service. In Microsoft, you will get it by the term Azure Functions. In AWS, you will have something called Lambda Functions, and in GCP, you will find the term functions, just functions, right? And in infrastructure as a service, you go ahead with some kind of commitment cost. For example, these are entire virtual machines that are being given to you, so you need to pay on an hourly basis. On in platform as a service, these are just functions that are being executed on a machine based on a trigger that you have set. So in here, you pay as close as to the nearest microsecond. You're built for, sorry, the nearest millisecond. You're built for the only the milliseconds that your code ran. And this is a very cost efficient method when you're not sure what kind of load you are going to get on your product. A platform as a service seems to be the most promising way to go forward with, because one, it can handle spiky load unlike any other provider, wherein in VM, in a infrastructure as a service method, you would have to set up load balancing and auto scaling in order to take care of scaling. But in platform as a service, the entire platform is a service for you. It's managed by your cloud provider. Scaling, security, dependencies, everything is managed. All you need to do is provide your code. And in GCP, apart from functions, there is another GAE, or the Google Application Engine, is another example of platform as a service in this world, right? And then we have SaaS, or software as a service. typically any application that provides some kind of online service, starting from your games like PUBG and Call of Duty to I think PUBG has been renamed to Battlegrounds, my bad, and to any other example that could be Gmail, YouTube. All those examples are basically software as a service based models. So we discussed about what is on premise, how cloud solved all these problems to uh, solve it for good for the enterprises, and then we talked about a few couple cloud providers, and then we discussed the shared responsibility model, in which identifies the cloud into three sections: infrastructure as a service, platform as a service, software as a service. We understood how to differentiate them, when to choose them. I think now you have a better idea about it, and some examples for that. So with that, I'll stop sharing my screen, and if you have any questions you can ask me in this chat. I'll be here for a while. If not, we can call it a day. Cloud computing provides dynamic resources you can scale as per your requirement. Makes sense. That's exactly what cloud does. Cool. I think there are no more questions to take on. So until next time, until the next event, maybe when we dive deeper into the cloud, we'll catch up again. Bye bye.